Okay, we're going to resolve now an equilibrium problem when all the equilibriums are not known. So there are some of them that we don't know about the concentration in the equilibrium. We need to calculate that. Okay, so the problem says that we have hydrogen and iodide that react together to give us 2 moles of hydrogen iodide. And it says that when 2 moles of each hydrogen and iodine are mixed, 2 moles each, in an evacuated vessel, 3.50 moles of hydrogen iodide are formed. So at the beginning, we have 0 of hydrogen iodide because there was nothing there, and we have 2 moles of hydrogen and 2 moles of iodine. And at the end, we have 3.50 moles that are going to be formed, so we put positive, and if we add them up, we have positive 3.50, which is the concentration that we have at the end. Now, how do we calculate the concentrations of hydrogen and iodide? For calculating the concentration in the equilibrium, we need to know how much was used up for this one. So we are going to use stoichiometry. So I'm going to make like a line here, not very nice, and we are going to look at the ratios. For each 1 mole of hydrogen, 2 moles of hydrogen iodide are formed. So when we form 3.50 moles of hydrogen iodide, the amount of moles used up should be 1.75, and the value for the iodine is going to be the same because the ratio is the same for both, 1 to 2 in this one, 1 to 2 and 1 to 2. So the amount that was used up is 1.75. Same here, 1.75. Well, when we form, we put a positive charge or a positive value. When we used up, we are going to use negative values. So the value in the equilibrium will be the difference between what we had before and what was used up. So in this case, it's going to be 0.25 and 0.25. Now, these that we have here are the concentrations in the equilibrium. So now we can apply the formula of the Kc. So Kc will be the concentration of hydrogen iodide to the second power divided by the concentration of hydrogen times the concentration of iodide. So in this case will be, we don't need the brackets again. We're going to put the decimal line and 3.50 square divided by 0.25 times 0.25. Now, Kc will be 3.50 square is 12.25 and 0.25 square is 0.0625, which the value of Kc is going to be exactly 196. Now, units of Kc. The units of Kc will be the concentration of hydrogen iodide, which is molarity to the second power, divided by the concentration of hydrogen to the first power times the concentration of iodine to the first power. So, oh, I'm sorry, I was putting molarity here, and I'm going to put the same here. Concentration will be molarity here too. So it's molarity squared and molarity squared, so in this case it's going to be none. There are no units. Okay, and that happens every single time that we have the same amount of moles in both sides of the equation. I hope you understood better and you can do the problems.